Alright, dear children of class 11 science, now we try to understand more about perfectly black body. Okay, now more or less you understood in the last YouTube video about the perfect black body. Now is that body which absorbs all the amount of heat, but that body which does not either reflect heat or transmit heat, but the amount of heat that is given to that body is completely absorbed by that body, is also known as perfect black body, also known as perfectly black body. That's why we can simply define perfectly black body as a body, a body which absorbs, a body which absorbs completely, completely all the radiation falling on its surface, surface. Okay, whatever, this is important also children, whatever be the wavelength, wavelength, and such body is called perfectly black body. Such body is called what? Perfectly black body. Okay, perfectly black body. Now out here the word black which is using out here is because black is a good absorber of heat, but perfectly black body means that body which completely absorbs heat. Okay, and this is true for radiation which fall on the body of any wavelength. Okay, that's why for perfect black body you have learned already that the relation A lambda equals to 1. A lambda equals to what? 1. Which means, okay, your absorptance, or we simply call it absorptive power, okay, simply equals to what? 1. Now since A lambda is same, it is same for what? All values of lambda. All value lambda means all value wavelength. Then for perfectly black body, that is then for what? Perfectly black body. For perfectly black body, we can simply write A equals to 1. We can simply write what? A equals to 1. This means your absorptance, okay, your absorptive power is same, that is always 1 for any wavelength for perfectly black body. Now since perfectly black body is a perfect absorber of heat, hence, okay, it is also a perfect radiator of heat, because good absorber of heat are the good radiator of heat also. Good absorber of heat is also a good radiator of heat. That's why when a perfectly black body is heated to a high temperature, see, perfectly black body is heated to our temperature, high temperature, then it emits radiation of all possible wavelength. That's why when perfectly black body emits radiation, it emits radiation of all possible wavelength. But this is true when that perfectly black body is heated at a very high temperature. But children, one thing you need to keep in mind, that no known body, as in the universe we know, no known body is perfectly black body. Perfectly what? Black body. But for practical purposes, okay, the Ferry, one of the scientists whose name was what? Ferry, F-E-R-Y, Ferry, who actually designed a perfectly black body which is actually used for practical black body, or that is only for practical purposes. But naturally if you see, okay, there is no body which is perfectly black body. Okay, so that is very important. Now the next part that we need to keep in mind is that it is not essential, children, this is very important, it is not essential that perfectly black body should appear black. Perfectly black body should appear what? Black. Actually, a perfectly black body is one which absorbs externally incident radiation of all wavelength falling on it. And this is also a body which emits radiation of all wavelength. Which emits radiation of what? All wavelength. When that body is heated to a very high temperature. That's why sun, as you know, emits radiation of all wavelength. As you know, sun is one of the body, okay, which emits radiation of all wavelength. So it may be called as a black body. Even it doesn't look black. Actually, it looks like white, but the sun also considered as a what body? Perfectly black body, because it emits radiation of all wavelength. Okay. Similarly, a thermally insulated closed oven is also very nearly a black body, though fire is burning inside it and it produces radiation of all wavelength, okay, but not exactly perfectly black body. So remember this part, children. This is a very necessary important condition to understand when the body is perfectly black body. So for that, the body has to absorb all the amount of heat falling on it, and that body also has to emit radiation of all wavelength. And at the same time, it is not essential that the body should appear what? Black. Okay, like I gave you the example just now that sun emit radiation of all wavelength, but we consider this as a perfectly with a black body, even doesn't look black. Okay. Now children, we will define two more terms and as per the radiation is concerned. Okay, and the two terms that we define now is three more terms to be defined. One is called emissive power, emissivity, and one is also called spectral absorptive power. Okay, so let me first define emissive power. Now children, first we try to define and understand emissive power. Okay, now if there is a body, let me just consider there is a body, okay, whose temperature is higher than the temperature of the surrounding. Suppose this is a body, okay, at temperature, suppose this is a body at temperature, okay, higher than the temperature of surrounding, temperature of its surrounding, temperature of its what? Surrounding, okay, temperature of its surrounding. Okay, so under this case what happened? The radiant energy, okay, I mean to say the emitted energy, okay, also known as radiant energy, which emitted from the surface of the body, will be higher than the what? Absorptive energy from the surface of the body, which means at a given temperature the rate of emission, okay, of this energy from this body will be higher than the rate of absorption of energy from the surrounding. Okay, so under this case what happened? The total amount of radiant energy that emitted by this from this surface of the body, okay, is depend upon two factors, okay, depend upon two factors at a given temperature. Okay, and the two factors are the amount of radiant energy is directly proportional to area of the surface in which the energy is emitted, and another is the radiant energy is also emitted from the surface, also depend upon the time in which the energy emitted from a given body. So if Q is proportional to A, the area of this surface, and Q is proportional to T, means T is the time for which the energy is emitted, then if we combine, then we write on Q is proportional to A into T. Q is proportional to A into T. And you know, when proportion sign is removed to equals to sign, you have to put some constant. Now this constant is actually expressed by letter E. So I am using small letter E. A into T. Okay, where this E is actually the what? Emissive power. This is the what? Emissive power. And this E is constant for a given body at constant temperature, and this E is actually called as what? Emissive power. So from this relation I can write E equals to Q by AT. E equals to what? Q by AT. So emissive power can be measured by Q by AT. Q means the amount of radiant energy emitted, and A is the area of the surface in which the energy emitted, and T is the time in which the energy is emitting. Okay, so from here we can even define the emissive power. So emissive power is the total amount of radiant energy emitted per unit area, per unit what? Area of the surface per second, per unit area of the surface per second. Okay, and this energy is called power is called what? Power, emissive power. And emissive power is also known as what? Radiant power of that surface. So children, whatever explanation and the statement which I had said just now, the same explanation I have written in the form of statement. The statement says that the total amount, means this total amount of radiant energy emitted per unit area of a surface per second is called what power? Emissive power, or also known as radiant power of that surface. So this is the statement of emissive power. Okay, now this emissive power can be measured, and measurement of emissive power is done by the unit. So the unit can be easily expressed. So unit of energy, SI unit of energy is what? Joule. Radiant energy is also joule. Okay, area SI unit is what? Meter square. Time SI unit is second. So we can easily express the SI unit of what? Emissive power. So I write down SI unit of E is given by joule meter square per meter square per second. Because meter square if I take in the numerator, per meter square, second if I take in the numerator, per second. So what is the unit, SI unit of emissive power? Joule per meter square per second. But this joule per meter square per second can also be written as watt per meter square also. You know why watt per meter square? Because joule and per second I write together, and there is meter square. And joule per second, as you have learned already, children, is what? Watt. And what is the SI unit of power? Because our SI unit is watt, and watt is equals to joule per second. So we can even write the unit as watt per meter square. So the SI unit of emissive power can be joule per meter square per second or watt per meter square. And children, one important note you have to write it down out here, that is, this radiant energy has different wavelengths. It has different wavelength, and its spectrum can be obtained. Different radiant energy has different wavelength, as I said earlier, and its spectrum can be what? Obtained. Just example, sun, and it give us what energy? Radiant energy in the form of heat and what? Light. And it has different wavelength. That the wavelength of the radiant energy produced by the sun can be observed in the form of spectrum, and this spectrum actually is called electromagnetic spectrum, because sun gives us electromagnetic waves in the form of radiation. And this spectrum consists of like ultraviolet spectrum, infrared radiation, or also called spectrum. Okay, then after visible spectrum. These are all the spectrum consist of radiant energy. Okay, now we have next term to define, that is called emissivity. And children, the definition of emissivity, and one more definition that we define, spectral absorptive power, and that you learn in the next YouTube video.